Hello, and welcome to another episode of Real World Analytics, What Schools Don't Teach You. This is another installment of my coffee series, where I discuss something that I consider interesting. Once again, I found something from LinkedIn. A recruiter I'm connected with, Emily, posted a nice infographic. I'll put a copy of it here. This links to an article on medium.com about the 20 data science projects at the core of every successful business. In addition to listing these, there's a link to a follow-up article, again by David Foster, called The 24 Essential Data Science Projects That Will Transform Your Business. I'm not sure where the extra 4 came from. This article is a little bit longer. As always, I'll put links to both of these in the description below, so if you'd like to go read them, I encourage you to do so. If you'd like to go get yourself a cup of coffee or another tasty beverage, I'll hit the pause. If you hit the pause button, I'll wait for as long as you'd like. So for those of you who read the articles, I hope you enjoyed them. For those of you who have a beverage, I hope it's tasty. And for those of you who just want to hear what I have to say, let's get on with this. So notwithstanding the fact that there's an extra 4 data science projects here to the business map, I want to talk in a little bit more detail about the business map, some of the problems that I've encountered looking at such a business map, and some of the kind of ways around it. Now, the author here is a consultant. He has a business called Apply Data Science, and so he's looking for ways to encourage businesses to consult, use his services to gain some of his expertise and to implement a more robust, shall we say, data science ecosystem within their organizations. And I fully agree with this. But there's a first step, and this may sound like an odd first step, but in my experience, most businesses don't know how many of these models they do or don't have. And you might think, well, that's kind of odd. If they have a data science team, don't they know what models they have? Well, yes, each individual part of the organization might know what models they have, but once you start scaling up, they might not know about others. So, for example, I worked on a small project looking at pricing optimization. We were looking to have a trial of some special pricing schemes to certain customers. And in order to do so, we built a small churn prediction model just to say, well, we think these customers are at the highest risk of leaving, and I don't care if it's a 80% chance they're going to leave, 50%, 10%, I don't care. Just these are the customers that we think are most likely to leave. It doesn't matter if it's well calibrated, but they're the ones that we want to extend this pricing to. So we had our little toy churn model living within our pricing model. Similarly, you may get something on the other side where the people in the churn modeling team are saying, well, we don't know if these people are going to leave or not. We're not sure what prices our competitors might be offering them. So we're going to build some little pricing model to simulate what our competitors are going to do. And now as a result, you have the churn modeling team with a toy pricing model, and you have the pricing team with the toy churn model. And are you going to count those as models that your bank has if it's not using those for kind of what they're intended for? That is, you're not using the churn model that the pricing team builds to predict churn, and you're not using the pricing model that the churn team built to do your pricing. So do you count them or not? And then you can run into other problems like if with the pricing team, some executives hear that you're predicting churn, they might say, well, the guys over in churn modeling have one of those. Why don't you use their model? And you're like, oh, okay, that makes sense. So, and then vice versa, that the churn modeling team who have this little pricing model say, well, there's a pricing model team, use their model. Okay, but then you can run into these cycles where if they have a high chance to churn, the pricing team says, well, okay, you can drop the price so that they're more likely to stay, but then that feeds back into the churning model that says, well, they're going to stay, so they're getting a good price, so they'll stay. Okay, so then their churn goes down, and that comes back to the pricing model. It says, well, if they're not going to leave, why are you giving them the special price? And you can just sit there and go around the circles. So that's one reason sometimes that you can get these little toy models sitting independently so they don't connect up. Another thing that might happen is if you do have the churn model feeding into the pricing model without the feedback, so you decide, I'm going to look at the probability they're going to leave, and I'm going to use that to influence my pricing, but then I'm going to cut the link that says pricing determines whether or not they're going to churn. Fine. Then if you get if the competitive environment changes so that the churn changes, and you update that model to reflect the new reality, then suddenly the inputs to your pricing model go off, and 1 month all of a sudden all your pricing changes, unless you have good communication that, by the way, we're changing the churn model, expect the impacts from into pricing. This is one of the reasons why I like using Shiny, because it kind of forces the organization to figure out how these two things fit together. That you have this churn model running and it feeds into this pricing model, so then how do they work together? What's the net impact going to be? In other times, you can get multiple models, like multiple real models. So for instance, in banking, if you're looking at churn, you might have a customer with 3 products. They might have a savings account, a credit card, and a mortgage. And if they end up refinancing their mortgage, did they churn? Well, the mortgage group says yes, but the credit card and the savings say no. And overall, at a high level, did you lose a customer? Well, yes, no. Did you lose a third of a customer? Do you value it in terms of the size of the mortgage versus the size of their savings and their credit card? Do you want to view the savings account, because that's money coming in, differently than the loan facilities, because that's money going out? How do you want this customer definition to work? So as a result, you might end up with these 3 different churn models. And again, once you go up to a high level, someone looks down on it and says, you've got 3 churn models, but they have different methodologies, they get different reports. We want all these to be the same. And as a result, you might get these centers of excellence where you say, no, we're going to get all our churn modeling capability and put it in one group. And then if you want a churn model, you go to them. Now, oftentimes businesses don't like this because they lose control of their own models. And if they want a model updated, or if they want a new model, they then need to go somewhere else and get it prioritized. And this lack of control is one of the political games that you may see getting played. Hopefully your managers will block that from you if you're on the front line, but it's something to watch out for if there's going to be a center of excellence forming. And of course, you can abstract that out to say all of our data needs, all of our analytics are going to be done by this center of excellence. And if you want any one of these 20 models or one of these 24, you need to talk to them. Sometimes it's not so easy to do that, because if I'm doing churn modeling and suddenly someone wants data visualization, I might not be the best at that. I might not know how to do text mining. If I'm going from using logistic regression to do text mining is quite difficult. So you can run into these problems where businesses don't really know what analytics is, and they don't really know what problems are the same and what problems are different. And the mathematical statement may be not the best way to communicate. Conversely, you can end up on the other side where if I'm doing churn modeling and one of the things on here is an attrition model, people may say, well, wait a minute, customers behave very differently than employees. And that's true. But meanwhile, the data scientists are kind of looking at each other saying, you have a binary outcome flag and a bunch of inputs. You build your logistic regression model. It works in either case. What's the problem? This is the same. So you can run into these problems where, first of all, businesses don't know what models they have. Secondly, they don't know which models go together, which ones use similar techniques to solve them. And finally, how do they all fit together? So what do you think? Have you ever had problems like this? Do you know what models your organization has? If I take it a step further, do you know all the models you've ever worked on? If you're working as a professional data scientist, you may see these things come and go. And if you can be quite liberal with what you've worked on, in terms of if a friend has asked you a question, you've worked on that model, even if it's outside your normal area. I'd be interested to hear from you. What do you think about the list of 20 or 24 different modeling types, different data science projects, and how many of them have you worked on? Thank you for watching, and I'll see you next time on Real World Analytics, What Schools Don't Teach You. Goodbye.